Alright, what's going on, everybody? In this video we're going to be talking about geometry proofs. Now, I know that a lot of students struggle with proofs, right? The whole idea of, okay, well, where do I have my givens, where do I go from there? And, what are all these different postulates and all that? We'll be talking about that in this video. So, in this video we'll be doing 10 problems, right? We'll be doing 10 different proofs, and all of those proofs will have, some different postulates in there that we're going to be using, like side, 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 angle, side, angle, angle, side, other stuff. We'll talk about CPCTC, and that's all things that we're going to review in this first section here. Okay, we'll talk about all those different postulates that we're going to be using today. Okay, we're also going to go through some key terms, okay, and things like the reflexive property, like vertical angles, right? We'll talk about what those different things are, because those are reasons that you're going to have to use in your two-proof column, okay, or your two-column proof, okay, and then we're going to be doing our practice problems right after that, okay, and so yeah, hopefully this will help you out. So, as a starter, we're going to talk about these different postulates, right? We're going to talk about side, 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 angle, all that good stuff. Okay? So when you're proving that two triangles are congruent, right, in a proof, a lot of what you want to look for is, do they have a specific combination of sides and angles that are congruent, right? So for instance, for side, 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 if we have two triangles that we know that these two sides are congruent, we know that these two sides are congruent, and we know that these two sides are congruent, well then we know that these two triangles have to be congruent. Okay? That's if they have all three sides that are congruent to each other. Okay? And that is side, side, side. Okay? And we'll talk about that in these two-column proofs. So if this doesn't really make sense right now or anything like that, we'll go over that during the two-column proofs in even more depth. Okay, so this is side, side, side. Basically, it's saying that if you have three sides that are congruent on each triangle, then the triangles are going to be congruent. Okay, and what does congruent mean? It means same size, same shape. Okay, next is side, angle, side. And basically what side, angle, side means is that, and you do these things in order, so you have two sides that are congruent right here, okay? You have an angle that is congruent, okay? And then you have another side that's congruent. Now it has to occur in this order, right? So you have side, angle, side, and the angle is between these two sides, okay? And if you want to think about it here, right, how do you know if, these triangles are congruent? By just knowing these three pieces right here. Well, think about it. If you know the length of this side, you know this angle, and you know this side, and you don't have these pieces, right? Well, if this triangle has all the same stuff as, this triangle has the same side, angle, side, the only other place that these lines can connect is right here, right? And so these triangles have to be congruent. Okay, hopefully that makes sense. Next we'll move on to angle, side, angle. Okay, this is another interesting postulate. Basically what it says is you have two angles that are congruent, you have a side that is congruent, and then you have another angle that is congruent, right? And just we're gonna draw that with 2. Right, we'll draw two little angle symbols just to denote that this angle is different from this angle. Okay, and you noticed before when we were talking about side, 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 and side, angle, side, we did the same thing with the sides. Okay, so that's the idea with angle, side, angle. So we have two angles and we have an included side. Alright, so that means the side falls in between the two angles. Alright, next we're going to talk about angle, angle, side. Alright, and this is kind of the last of the 4 main postulates here. And what angle, angle, side tells you is that you have two angles that are congruent, right? And then another two angles that are congruent. And then you have a non-included side that is congruent. Okay, and this, knowing these things, will also tell you that these two triangles are congruent. Okay, and here they will be congruent by angle, angle, side. Okay, and so those are your 4 postulates. You have side, 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 angle, side, angle, side, angle, and angle, angle, side. Awesome. So let's move on to CPCTC, and then we'll get into HL. Okay, what CPCTC stands for is that congruent parts of congruent triangles are congruent. And by the way, I can take these lines off of the paper. I'm not sure which you guys like more. If you guys would rather have me have the lines on the paper or not, just leave that in the comments down below, because I'm not sure exactly what to do yet. But yeah, so what this whole CPCTC thing means is that you have, let's say these 2 triangles are congruent, right? So let's say this is congruent to this. Okay? Let's say that they're congruent by side, 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 right? Which, remember, that means that all 3 sides are congruent. Okay? Well, now we also know by CPCTC, right? We will also know that these angles are going to be congruent as well. Right? Because for triangles to be congruent, everything here needs to be the same. Okay? Everything will have to be the same, right? So once we've proved that these triangles are congruent by angle side angle or angle angle side or whatever, we know that everything is true, right? And all that stuff. Okay? So that's the idea with CPCTC, and it's really, really helpful in proofs. So, what you'll start out doing is you'll start out proving that 2 triangles are congruent, and then from there you can find that other things are also congruent. And so we'll talk about that when we go through our proofs. Okay, the next thing we'll be talking about is the hypotenuse leg theorem. And this states that when you have 2 right angles, okay, and you have the hypotenuses of these 2 triangles that are congruent, right? So the hypotenuse is the longest side, remember? So the hypotenuse is this thing, and it's this thing. Okay, so you know that these 2 things are congruent, and you also know that you have a leg that is congruent, right? Well, then you know that these 2 triangles are congruent by the hypotenuse leg theorem, okay? And this is really helpful when you have right triangles, but you might not always get right triangles, and really this does not get used nearly as much as all the other postulates that we've talked about thus far. Okay, and so you really need to not know this one so much, but know these 4 right here: the side, side, side through angle, angle, side, and of course you need to know CPCTC. Okay, now you might be wondering, like, how do you actually know that these things are congruent with HL? Well, actually, it's through the Pythagorean theorem. So if you know that these 2 sides are congruent, right? If you know the lengths of these 2 sides, then by Pythagorean theorem, you can find the length of this side, right? And if these lengths are the same, then these lengths will be the same, right? And so that's kind of interesting. So now you will know that this is congruent by side, 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 right? And you may be wondering, well, why do we have to have a hypotenuse? Why can't we just have a leg, right? Well, we can, right? This is also proving that these 2 triangles are congruent, but by a different theorem. We don't call this like the leg theorem. We call this side, angle, side, right? This is side, angle, side. Okay? And so if you know that, you'll be set. All right? And that's pretty much all the different, postulates, theorems that you need to know. Okay? Now here are a couple non-postulates. Here's a couple that really trick students up because they think that they've proved 2 triangles congruent, but they actually haven't. Okay? Here's an example of 2 triangles that really don't look congruent. They shouldn't to you, right? Well, these have 2 congruent sides, and then another 2 congruent sides, right? And they also have an angle that's congruent. Okay? And these things, you would say, okay, well, you have an angle, a side, and a side, right? And the fact is that these triangles aren't congruent. So this postulate, right, and if you write it differently, SSA, they don't work. Because as you can see here, we've came up with two triangles that aren't congruent. Okay, the last thing is angle, angle, angle. So really, you can have two triangles that have all the same angles, but they can have different sizes. Okay, and so they're not congruent because they don't have the same size, right? Congruent means same size, same shape. These have the same shape, but they do not have the same size. Okay? So these are two things that, just because you have all angles congruent does not mean that the two triangles are congruent. And just because you have two sides and a not included angle, right, that doesn't mean that you have two triangles congruent. Okay? So that is the red section. Now we're going to move on to the orange section on key terms. Okay? So now let's talk about, like different things like perpendicular lines, vertical angles, reflexive property, all that different stuff. Okay? We'll start off easy with what perpendicular lines are, right? If we say that segment AB is perpendicular to segment BC, okay, what we're saying is that they form a right angle. And remember, a right angle is just 90 degrees. Okay? That's just a 90-degree angle. And so that's all that perpendicular is telling you. It's really nice because, then you end up with right triangles. You can do different things with right triangles. Okay? And we'll talk about, we'll see in proofs later on where we have perpendicular lines and we can do different things with them. Next, we'll talk about vertical angles. Okay, so vertical angles, it's when you have like two lines just passing through each other, right? You'll get that this angle is going to be equal to this angle. Okay, why? Because you kind of see how they're like back to back. We call these vertical angles. And these two angles are going to be congruent as well. Okay, and so that is what vertical angles are. Now note that you can't have something like this, right, where the lines are kind of going into all different directions. Right? You can't have something like this and say that this angle is congruent to this angle. They need to be two straight lines passing through each other. And then you'll know that this angle is congruent to this angle, and this angle is congruent to this angle. Okay? So that is what vertical angles are. Moving on to the reflexive property. So there are times where, you'll want to be proving that these two triangles are congruent right here. You'll want to prove that this triangle and this triangle are congruent. Okay, and you might want to do that, let's say, by side, 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 right? And let's try to remember what side, side, side means. Well, it means that all the different sides are going to be congruent to each other, right? So the triangle will have three pairs of sides that are congruent to each other. Okay, and here's the thing though, these two triangles share a side. Okay, and so we can't say that the side of one triangle is congruent to the side of another triangle because they're the same side. And so what we say is that this segment is congruent to itself by the reflexive property. Okay, that's what we call the reflexive property, and we denote that with a little x. Okay, so instead of drawing three lines, we would draw it with an x. Okay, and we'll again see that later in proofs. Now, a couple different things that we'll talk about too. We'll talk about midpoints and segment bisectors, right? With a midpoint, this just means that, you are in the middle. Like if you say that C is a midpoint of segment AB, that just means that, C is directly in the middle of A and B, right? And that sounds simple enough. But you also have to understand what that means in terms of, when you're trying to prove something, right? And that's that segment AC is going to be congruent to segment CB. They'll be the same length, right? And so that's really good to know, right? If you know that segment AC is congruent to segment BC, we'll call it BC, right? Now you have something that you can work with in a proof. Okay, so that's why midpoints are really nice. Okay, and expanding on the whole idea of midpoints, we have things that are called segment bisectors. Okay, and so how you would see this written, like on a proof in a given or something like that, is that DE, segment DE bisects segment AB. What this means is that this segment DE is cutting through AB at AB's midpoint. Okay? And so, you won't see that like you won't see that C is a midpoint of AB. What they'll tell you is they won't tell you this, they'll tell you DE bisects AB, right? And from there you should know that C is a midpoint of AB. Okay? And then from that you can also say that AC is congruent to BC, right? Because if this is the middle point, right, then we know that these two sides would have to be the same length, right? AC would have to be the same length as BC or CB, however you want to say it. All right, so that's the idea with a segment bisector. Now you also have something called an angle bisector, and I'll give you a guess as to what this is, right? We see that a segment bisector will cut another segment off at its midpoint. What do you think an angle bisector will do, right? Well, here we have that segment BD bisects, we'll call this angle ABC. Okay, what that means is that it's cutting straight through the center of this angle. Okay, it's cutting straight through ABC. And so what that means for us in a proof is that angle ABD is congruent to angle DBC. Or we want to say it kind of in the same order, right? So ABD is the same as CBD. Okay, so hopefully you see that, right? We kind of always end on D. Hopefully you see like the symmetry there. Okay, so we'll say angle ABD is equal to angle, or is congruent to angle CBD. All right. So anyways, that is the idea of an angle bisector. That's what it's good for. Okay, and then here's how you would see it stated on a proof. Okay, and we'll see that again when we talk about our proofs, which is actually the next thing that we're going to talk about. Okay, so one thing I will note before we get into these proofs, okay, make sure you understand everything we've just talked about. Make sure you understand side, angle, side, all that stuff, right? Reflexive property and vertical angles. Because if you don't understand that, proofs are going to become a nightmare, and you don't want that at all, right? Nobody wants to have a nightmare of a homework or a test, So make sure you understand that, and then we'll get into these proofs. Okay, so assuming that you do understand that, let's talk about this. So here's our first proof. Okay, and here we already have some of those definitions that I'd say would pop up, right? We're talking about bisections here. Okay, so our first problem says we have this shape over here, and we have given that AC and BD bisect each other at E. We want to prove that triangle AED is congruent to triangle BEC. Okay, and so I'm going to put the lines back on here actually, because I think I like them a little bit better. Okay, especially for when we're going to be writing things out in our 2-column proof. Okay, so let's figure out what we're actually trying to do here. That's a great start, right? We want to prove that these two triangles are congruent. Well, where are these two triangles? We're talking about AED, and we're talking about BEC. So we want to show that those two triangles are congruent. Okay, and so how do we start off with that? Well, the first thing that I would recommend you do in any proof is start by writing down one of your givens. Okay? So we'll write down that AC and BD bisect each other at E. Okay, that's a good start. So we'll go ahead and write that down. AC and BD bisect each other. Oops. At E. Okay, the reason for this is that it was given in the problem. Okay, great. So we wrote our first statement down. That was just our given, right? This was our entire given. So we've used that given up. So what does that tell us, though? Right? That's kind of what we want. So we're given this, and we want to know, what does our given tell us? Well, since we are talking about bisections here, right? We're saying that segment AC and segment BD bisect each other. Right? That means that they're passing through each other's midpoints, right? And so what we know is, right, since angle AC and angle DB are bisecting each other, we know that this side and this side are congruent, right? Because DB passes through the midpoint of AC, and AC passes through the midpoint of DB, and so these sides are going to be congruent. Okay, and we can all write that in one statement. Right? We can say that segment AE, right? We'll stop at E, so just this part right here is going to be congruent to CE. Right? We'll write it this way so they're kind of ending at the same point here. And we'll also write that DE is going to be congruent to BE. Okay, the reason for this, well, that's what a bisector means, right? So it's called definition of a bisector. That's what our reason is. Okay, and so like whenever you are trying to give a reason, right? Here's a little tip. Whenever you're trying to give a reason, and it's kind of like, well, that's what a bisector is, or that's what that thing is, right? It's just, you just say definition of blank. Okay, and we'll see other definitions in the coming proofs. Okay, so now that we know that these things are congruent, what else do we know? Right? Let's look at this. We've kind of ran out of what our givens are telling us, right? Our given, we wrote that down, and it told us this. So what else can we see from this shape here? Well, remember what vertical angles are, right? We have two lines passing through each other. We have AC and BD that are passing through each other. And so these form vertical angles. Now, which set of vertical angles would I want to identify? These or these? Well, remember what two triangles we're trying to find congruent, right? It's this one and this one. So we should probably identify the angles that are in those triangles, right? And that is going to be this angle and this angle. Okay? And you can either write this down as, like, you can call it angle AED and say that it's congruent to angle BEC. Or what you can do is just like number it. Okay? You can number your angle and call this angle 1 and this angle 2. And you can say that angle 1 is congruent to angle 2. Right? Your reason for this, you just write down that they're vertical angles. Okay? So there you go. And so now, is there, we can ask ourselves a couple things, right? Is there anything else that we see? Okay? Well, identifying the other vertical angles doesn't really seem to help us, but we shouldn't even be looking for other things at this point, because we've already proved that these two triangles are congruent, right? Look what we have. We have a side, an angle, and a side that are congruent. And then we have a side, angle, side that are congruent, right? And so we can already say that these two triangles are congruent, right? Triangle AED is congruent to triangle BEC. The reasoning for this is SAS, right? Side angle side. Okay, and there you go. We've proved that these two triangles are congruent. So as a recap, right, we started by writing down our givens. Okay, we identified what our givens tell us. Okay, in this part, we identified what our givens tell us. Okay, and then we looked for other things in the proof, right? Because we saw that what our givens gave us was not enough to prove that these two triangles are congruent, right? All we had from our given was that these two sides are congruent. Okay, and so we had to identify these vertical angles, and then we took a look back and we were like, oh yeah, we have a side angle side. And so from that, we were able to prove that these two triangles were congruent by side angle side. Okay, so that is our first problem. Let's move on to problem 2. So problem 2, we have our shape over here and we have our given, right? Our given is that segment AC is congruent to segment CB, and we also have the D is the midpoint of segment AB. And what we want to do here is we want to prove that triangle ACD is congruent to triangle BCD. Okay, and so let's start off here, right? Remember what I said we do to start off. We're going to write down our givens. Okay, so we'll write down that AC, segment AC, is congruent to segment CB, right? Because that's given. And so we'll identify that on the triangle here. We have AC, we have CB. Okay, and that's a great way to start off. Does that tell us anything about our triangle yet? You know, is there anything else we can pick from? No, I don't see anything that, you know, that obviously tells us. So let's move on to our next given. D is the midpoint of segment AB. Right? The reason for that is because it is given. Okay? Now, does this tell us anything? Well, yeah, right? Remember in the last problem, if this is the midpoint, then that means that this segment right here is going to be congruent to this segment, right? They're the same length. And so we'll write that down. Segment AD is going to be congruent to segment BD. And if you're looking for a reason, remember it's the same idea as from before. You know, why are these two segments congruent? Well, that's the definition of, you know, what a midpoint is, right? A midpoint will tell you that. So that's a reason. Say definition of a midpoint. Okay? And so there you go. You have your three statements here. Okay? And, well, is there anything else that we can look at, right, to prove that these two triangles are congruent? Which, by the way, these two triangles are, let's get a yellow here. We have this one, right, ACD, and we have BCD. So these two triangles are what we're trying to find congruent. You know, that's also something that you should start off with in the beginning of the problem. So, you know, you want to know what you're actually trying to prove here. Okay? Well, to prove these two triangles are congruent, remember what I said about the reflexive property in the orange section, right? You know, these two triangles are sharing a side here, right? And if we could prove that, you know, that side was congruent to itself, well, then we would have side, 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 right? We would have three sides on each triangle that are congruent. And so what we do is we just, you know, we put a little X here, right? Because this is obviously congruent to itself, right? Because it is itself, right? That, you know, that would make sense. And so we write that segment CD is congruent to segment CD. How? By the reflexive property. Okay, and now that we have this, well, now we have side, 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 right? We have a side here, side here, side here, side here, and then we have our third side. which is congruent to itself. And so we get that these two triangles are congruent, right? Triangle ACD is congruent to triangle BCD by SSS. All right, and so there is your another postulate in action, right? In the last problem we talked about side angle side, and this problem we got to see side side side. Okay, and so that is it's pretty interesting. So let's just review quickly what we went over, in this problem, right? We started out by writing down our givens, right? We tried to see, what did our givens tell us, right? That was the second step. And then, since again our givens and what they told us was not enough to fully prove that these two triangles were congruent, we had to look for something else. And at that point, you're looking for the reflexive property, you're looking for vertical angles, different things like that. And here we found that these, we had a reflexive property that we could use, right? That segment CD was congruent to itself. And from that, we were able to use side, side, side. Okay? So that's basically the process that we're going to use in the entirety of this video. Okay? So that's why I really want to review this and hammer this down, because it's a good process to use when you're trying to prove something. For problem 3, we have a interesting looking shape right here. Okay? And we have given that segment DB is parallel to segment AB, or sorry, that is perpendicular, that says perpendicular. Segment DB is perpendicular to segment AB, and segment AC is perpendicular to segment DC, and segment BE is congruent to segment CE. We want to prove that these two triangles are congruent. Triangle ABE and triangle DCE. Now, which two triangles are these? Well, triangle ABE is right here, right? And triangle DCE is right here. So we want to prove that these two triangles have the same size, the same shape. Okay, let's start by writing down our givens again. Right, that's a great start in any problem. So we have that DB is perpendicular to AB, and since we're kind of on the topic of perpendicular, I'm also going to include that segment AC is perpendicular to segment DC. Okay, and the reason for this is that they are given. Now, what does this mean? So segment DB is perpendicular to AB, right? And we're talking about, let's identify where it is that we're talking about something. We have DB and AB right here. Okay, if they are perpendicular, well, that means they form a right angle, right? And also, right, and so I'll just get rid of this so we can highlight something else. We have AC right here, which is going to be perpendicular to DC right here. And so there should be a right angle right here as well. Right? And if we now have two right angles, right? Well, that means that they're congruent to each other, right? Because, right angle, that's 90 degrees. Now you have another 90-degree angle. So they're the same angle, right? They're the same. They're both 90 degrees. And so we can say that angle B is congruent to angle C. Okay, right here. Angle B is congruent to angle C. And so that'll be our next thing. Okay, the reason for this, what I would say, is that perpendicular lines form right angles. Okay, that's what I would say. Because, now that you have the perpendicular lines form right angles, the right angles are congruent to each other, therefore these angles are congruent. Okay, so there's a great start. So now we have, we started that problem just like we've started every other problem, wrote down our given, we wrote down what that given told us, and now let's write down our other given. Our other given is that segment BE is congruent to segment CE. Okay, and let's mark on our paper where that is, right? BE is right here, right? That's this piece right here. And we know that's congruent to CE right here. Okay? And so we're doing all right. All right, we have a angle and a side. Angle and a side. So if we have an angle and a side, there's a couple different things that could happen, right? We could show side angle side, right? Meaning that these two sides would have to be congruent. Or we could prove that we could get ASA, right? We could get angle side angle and prove that these two angles are congruent. Well, I think we know that these two angles are congruent, right? How do we know that they're congruent? They're vertical angles, right? There are two lines passing through each other, they form vertical angles. And so that's perfect for us. And so we're actually going to be able to use ASA here. Okay, so let's write that. I'll write the angles the other way this time. So here we won't label them angle 1 and 2. Here we'll just label them as, with letters. So we'll label them as, let's see here, angle AEB is congruent to angle DEC. Okay, how are they congruent? Well, they're vertical angles. Okay, and so now we have angle side angle, and so we know that these two triangles are congruent. Okay, these two triangles are congruent by ASA. Okay, and that's it. So these proofs are getting, not really any longer, I guess. I mean, we're still, we have about 5 statements, and that's, I guess, your pretty average proof. We're going to get into some harder ones later where you might have to have like 7 statements, but again, you're still following the same process, and we'll go through it once more because I really want to nail this into your head, because this is the way that you can do proofs. Okay, you start by writing down your given. You identify what your given is telling you. Okay, and then if there's any other givens, you write those down too. That's those segments being congruent. If you just have that any segments are congruent, it really doesn't tell you anything other than the segments are congruent, right? But yeah, so we didn't have that given told us anything. We then saw, okay, we have an angle and a side, right? We have an angle and a side, and so we can either have a side to get SAS, or we can have angles to get ASA. And we saw that, okay, well, that would be 2 angles, right? Because we know that those are vertical angles. So we identified that, and then we just said ASA. Okay? So moving on to problem 4. We're almost halfway done here, guys. Okay, and hopefully you're feeling a lot better about these proofs. So we're given that angle 3 is congruent to angle 4. Okay? And we're also given that segment GH will bisect angle JGK. Okay? And we want to prove here that angle J is congruent to angle K. Now, angle J, that's right here. Angle K, that's right here. Okay, so we want to prove that. But let's start again by writing down our givens. Angle 3 is congruent to angle 4, and I guess we can't, I'm not going to say that they're right angles because, I guess we might not know that for sure yet. Just by looking at it, you can see that they're right angles, right? But let's just write this down for now. Okay, angle 3 is congruent to angle 4. Great. Now, does that tell us anything? Well, no, not really. So, it's just that 2 angles are congruent. Does it tell us anything else is congruent? Well, no. Let's also write down that segment GH is going to bisect angle JGK. That's given. Okay, great. Now, what does that mean again? Let's try to remember what our definitions told us, right? what does it mean if we have a segment bisecting an angle, right? If we have GH, right, which is bisecting GGK or JGK, right? Well, that means that this segment is cutting directly through the middle of the angle. And so what that means, right, is that angles 1 and 2 would have to be congruent, right? They have to be the same, or else GH wouldn't be splitting through the center and therefore would not be bisecting angle JGK. Okay? And so we write that down. Angle 1 is congruent to angle 2. How? Because that's just the definition of an angle bisector. You can write angle bisector. Okay? And so then we can move from there and look at what we have, right? We have that we have angles that are congruent, and then we have angles that are congruent. And so we're pretty close to being able to prove that, you know, this triangle and this triangle are congruent. Of course, that's not what the problem was asking, right? It was asking that angle J is congruent to angle K. But remember that, you know, proving the two triangles are congruent, if you have time when you can prove that any two triangles are congruent, do it. Like, seriously do it, because if you can prove that two triangles are congruent, you can use CPCTC to get a lot of other stuff, right? And you want that other stuff because it could be useful for what you're trying to do, okay? And for instance, you know, here we have that angle J and angle K. Well, they are within these triangles, right? And so if we prove that these two triangles are congruent, well, these angles would have to be congruent, right? Everything in the triangles would have to be congruent, right? And so that's why proving the two triangles are congruent is always a good idea. Okay? Here we know that, you know, we have an angle, we could have a side in between there, right? Which is this side right here. And then we would have angle, side, angle, right? And we know that this side is congruent to itself, right? It's the same side shared by both triangles. And so we have that segment GH is congruent to itself by the, remember what that's called? It's called the reflexive property. Awesome. So, moving on from there, right? We now have that these two triangles are congruent. We'll say that triangle JGH is congruent to triangle KGH. How? By angle, side, angle, right? We have two angles, we have sides right there, and then we have angles, right? Notice how, and hopefully you're not getting confused with this at all, but notice how this isn't like angle, angle, side, right? Because we're kind of doing this in order, right? We're doing things that are right next to each other. So these angles are not right, you know, like they have a side in between them. Okay? If they didn't have a side in between them, if it was these two angles and some other side over here, that would be angle, angle, side, right? But when the side is in between the two angles, we put that letter in between the two angles, right? We put the side in between the two angles here. And that's why we call it angle, side, angle, rather than angle, angle, side. So now that we know this, we got one more step here, okay? And that's to show that angle J is congruent. Oop, that was a bad congruent symbol. To angle K. We will know this because since these two triangles are congruent now, we know that the angles are congruent, the sides are going to be congruent, right? But more importantly, what we're trying to prove actually is congruent, right? And we know that because congruent parts of congruent triangles are congruent, Okay, and there you go. There's number 4. So again, we're almost halfway through here, but we've been going for quite a while now. So if you'd like to take, a quick 5-minute break or something like that and just come back to the video, I think that'd be a great idea. I don't want you to burn out at problem 6 or problem 7, right? I'd like you to be able to get through the video and get as much out of this as possible. Okay, so just try to take a break here, and then we'll come back. Okay, so assuming that you've done that, let's hop into problem 5. And if you want to give this problem a shot on your own and then come back to me later, I definitely recommend it. So here we have a really odd looking shape, and we were given that angle ACD is congruent to angle BDC. Okay, and we were also given that segment AC is congruent to segment BD. Okay, so we're given a couple different things here, and we want to prove 2 different things actually. First, that we have 2 triangles that are congruent here, ACD and BDC. Let's identify which ones those are. We have ACD, okay, and so that's this triangle, and we have BDC, so that's this triangle. Okay, so hopefully you can see those 2 guys right there, right? We want to prove that they are congruent to each other. And then from that, we want to prove that angle 1 is congruent to angle 2. Okay? And you should notice now, right? How are angle 1 and angle 2 being formed, right? They're part of these triangles, right? Angle 1 is right here. That's part of this triangle that I just drew in blue. Okay? So the idea is, if we can prove that these 2 triangles are congruent, well then their angles, angle 1 and angle 2, would also be congruent by CPCTC, right? Because those triangles, right, these are their identical angles on both of these triangles, right? And so if we know the triangles are congruent, then these angles are also congruent. How? By CPCTC. So let me finish writing down our givens here. We have the angle ACD is congruent to angle BDC. Okay, that's given. We also have that segment AC is congruent to segment BD. That's given. So let's go mark those on our triangle here. We have AC, we have BD, and we have ACD, which is this entire angle, congruent to BDC, this entire angle. Okay, so now, right, we have let's see here, sorry, I'm just fixing something. All right, so now we have 2 sides that are congruent, right? We have 2 angles that are congruent. Okay, and so we could use a side here, right? We could use a side, couldn't we? We could have these 2, we could have, side angle and then a side right here, right? This is part of that big triangle. Or we could have angle, side, angle. So can we prove that angle A is congruent to angle B? Right, so those are the things that you should probably be thinking at this point, right? How can we prove that these 2 triangles are congruent? Right? And you might think, okay, well, what about these vertical angles right here? Right? What about those? Well, does that help us at all? I don't really see how that would help us, right? They're over here. And that really doesn't give us anything because they're not part of those bigger triangles. So I wouldn't even worry about those vertical angles, right? We're more focused on, can we get these 2 angles to be congruent, or can we get this side to be congruent to the other side of the other triangle? And well, this side is shared by both triangles, right? And so we know that it's congruent to itself, right? By reflexive property. So that would be a lot easier to do than trying to prove that angle A and angle B are congruent, because I'm not even sure how we would do that right now. So angle CD, or sorry, segment CD is congruent to itself by the reflexive property. And so now look, well, what have we just formed? Well, we have side, angle, side, side, angle, side. Okay, and so we can say that these two triangles are congruent. Triangle ACD is congruent to triangle BDC by side, angle, side. Awesome. Okay, and so now we have A proved, right? We have the first piece proved. And remember that angle 1 and angle 2 are part of these two triangles, right? Angle 2 is this part of the triangle, right? And angle 1 is this part of the triangle. And because congruent parts of congruent triangles are congruent, we know that these two things have to also be congruent. So we write that angle 1 is congruent to angle 2 because of CPCTC. Okay, so hopefully that makes sense, right? And again, we've just been following this same process the entire time. Wrote down our givens. They didn't really tell us anything else here because they were just stating that things are congruent. Okay, if we have givens that tell us something, they're gonna not say that something's congruent. They're gonna say like, segment GH bisects angle JGK, right? That would tell us something because it's not already saying that things are congruent, right? Angle 3 is congruent to angle 4. That told us that something is congruent, and so there was nothing off of that that we could kind of spin off. Okay, and so that's the idea with this, and yeah, hopefully this video is helping you so far. We're now halfway done with our proof problems, and let's get into this back half. So we have another pretty similar looking triangle to some other stuff that we've been dealing with, right? And we have that we're given angle TQR is congruent to angle TSR, and we have that segment TR bisects angle QTS, right? If you're following what I was just saying, this given, we're not going to have anything else that we can get off of that because, it's already stating that things are congruent. But since we don't have things being stated as congruent, we just have things, in our second given here, it's just saying that things are, being bisected, right? From that idea of bisections, we can say that other things are congruent. Okay, and so there's going to be things that we can pull off of this given. Okay, but we want to prove that these two triangles are congruent. What are those two triangles? Well, let's take a look. We have triangle QTR, and we have triangle STR. Okay, so it's the same two triangles as we have seen in the past. So let's start by writing down our given. We have the angle TQR is congruent to angle TSR, right? Those two things are given. And then we have that TR, let me erase that, there. TR bisects angle QTS. Okay? And the reason for that, well, that is also given. Now, what does this second given tell us, right? TR bisects QTS. Well, let's identify what that actually is on our triangle. We have TR, and that's bisecting QTS, which means that our angle right here, right, which means that we have our angle here, and since this is bisecting it, well, now we know that if we have two separate angles here, 1 and 2, they would have to be congruent to each other, right? Because TR just cuts through the center. Okay? And so we know that angle 1 would be congruent to angle 2, right? By the definition of angle bisector, right? That's the idea of what an angle bisector actually does, right? It cuts through the center of QTS, right? And so it forms two identical angles. let's move on to our next piece here, right? So we have that this is true, and from this, right, and I didn't also write down that TQR right here is congruent to TSR. Okay, and so now we have angles that are congruent and another set of angles that are congruent, right? And so we could either, let's see what we can do here. We have two angles. We can either do, we have angle side, right? Which means that we would have to have a non-included side, right? Not this thing, but we're talking about like this thing, right? Which isn't between these two angles, or this thing, right? So that would give us angle side. And we also could do angle side angle, right? Because we have two angles. They have an included side, right, that is between the other pair of congruent angles. And so that would be angle side angle. So which one do we go with here? Well, maybe you saw that when I was talking about angle side, we were talking about two angles and a side here. And we know that that side, right, is shared by both triangles. And so we know that segment TR, right, that line going down the center of the two triangles, is congruent to itself by the reflexive property. Okay, and because we know this, we can draw our little X here, right? And we see that we have angle, and since the side isn't between the two angles, right, it's not included, so we don't include it when we write it out. This is angle and a non-included side, so it's called AAS. And so that's how we know these two triangles are congruent. So we write that triangle QTR is congruent to triangle STR by angle side. Okay? And so that is number 6. Let's move on to number 7. Okay? So for this one, we are given that segment AD is congruent to segment CB, segment DC is congruent to segment BA, and we also have that G is the midpoint of segment BD. Okay? So remember, our givens that have congruences, right, those are kind of just dead ends, right? They're telling us that something's congruent. That's all they're telling us. But things that aren't telling us congruence, like G is the midpoint of BD, well, maybe there's some things that we can pull from that, right? Or else it probably wouldn't be given in the problem. So let's start by writing out our givens. Okay? The AD is congruent to CB. That's given. And actually, with this statement, we have other things that are being congruent, so we'll just add it on. That DC is going to be congruent to BA. Okay, so that's all given. That's all nice and dandy. Okay, and we also have that G is the midpoint. Of BD. Okay, what is that telling us? Well, if G is the midpoint of BD, that means that it's splitting BD in half. And so this little part right here is going to be the same length as this little part. Right? So we write it like this. And so we can say that segment DG is congruent to BD, or BG, right? Yeah, BG. All right, and that, right, the reasoning for this is the definition of midpoint, right? That's the idea. That's what a midpoint means. Okay? So that's a great place to start, right? We now have our givens all set. Okay? And so what do we go from here, right? And actually, I don't think I wrote out these, right? I didn't write out AD is congruent to CB. and I didn't write out that DC was congruent to BA. Okay, well, hopefully you can see right now that we have some good stuff going on, right? It looks like we have three sides that are all being congruent here, right? Or three different things. This is kind of split, right? So it's not like we have like a side yet. We're gonna have to do some magic to this. All right, we're gonna have to do some work still. But remember what we're trying to prove here, and I didn't actually even talk about this yet. So it'd probably be good for me to say that a little bit sooner, but we're trying to prove that triangle ADB is congruent to triangle CBD. Okay, that's the first thing. And what are those triangles? We're talking about ABD here and CDB. Okay, that's those two triangles. And while we have talked about how these two sides are congruent, right, this thing and this thing, that doesn't really help us with these triangles because their entire side isn't just these parts, right? It's them combined. It's the whole entire thing. Okay? And so to get our side, we would just have to use the reflexive property here, and I'll just write that with I'll just write an X here, right? That this side is congruent to itself, right? And the reason for that, right, why I'm even talking about that is because these two triangles share that side, right? We already know that this side is congruent to this side, and this side is congruent to this side. Now we just have to show that this side is congruent to itself. And that's by the reflexive property. And so we write that segment DB is congruent to itself by the reflexive property. Awesome. Okay, and so now that we have that, we have our first part basically done, right? We know that those two triangles would be congruent because all their sides are congruent, right? That's side. ADB is congruent to CBD. Okay, and that is by side. Awesome, so our first piece is already done. Now let's talk about these two angles here. We're talking about ABD and CDB. Where are those two angles? Well, they are here, right? That's ABD. And CDB is going to be right here. Okay? Now, if you've talked about parallel lines in your class yet, hopefully you'll be able to see that these are actually alternate interior angles. But we're not talking about that right now. We're not talking about two parallel lines, right? What we're talking about is how, since we already know that these two triangles are congruent, we know that these two angles are congruent, right? How? Well, you know, they're the same angle on both triangle, and so we know that they're congruent by CPCTC. Okay? And so we'll write that down. Right, and you know, we can only use CPCTC because we've already proved that these triangles are congruent. Right? If we hadn't have done that yet, well, we wouldn't be able to do that. Right? Because we have to know that we have congruent triangles, right? That's the whole idea of what CPCTC stands for. Congruent parts of congruent triangles are congruent. Right? So that is our first two things done. Now we got to also figure out that if segment FG is congruent to segment EG. Okay? So we got to look at this here. Well, segment FG is right here, and segment EG is right here. Okay? And so what do we do with this? And remember, we also have that these two angles are congruent now. We just showed that. Well, here, you know, it doesn't seem obvious how we can already figure out whether these two sides are congruent or not, right? So what we might have to do here, right, and I can see a lot of people getting stuck here, right? I think I definitely got stuck when I was originally looking at this, right? We have these two little triangles here. And so if we can prove that those two things are congruent, maybe we can show that this side is congruent to this side, by CPCTC, right? Because if we have those triangles are congruent, we know that all parts of them are congruent, right? All corresponding parts are congruent. And so what do? Well, is there anything else of these little triangles that we can point out? Well, maybe you might see some vertical angles here, right? So we can call this angle DGE and angle BGF. So let's write that. Angle DGE is congruent to angle BGF, right? And that is because they are vertical angles. Okay, and now that we've said that, look what we have. Angle, side, angle. Angle, side, angle. So now we have that those two triangles are congruent. Okay, and so that's perfect. We write that triangle BGF is congruent to triangle DGE. Right, and we know that by angle, side, angle. And so we know that all the corresponding parts of these triangles are congruent. How? Well, CPCTC, right? That's something that we know. And so we know that EG is congruent to FG. That's by CPCTC. So that's a lot of work. That's a very big proof, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 statements, right? That's as long as it's going to get. Okay, you shouldn't have any proofs that are really longer than that. But really, that's what the idea of proofs entails, right? We write down our givens, okay? We kind of try to figure out from our givens, what are they telling us? Is there anything else that we can point out in those triangles that are congruent, right? And if we know that, we can start using angle, side, angle, angle, side, or hang on, angle, side, angle, side, angle, side, angle, side, 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 right? We use that. We prove triangles are congruent. We use CPCTC. We go from there, right? So while it seems like a lot of different stuff, you can kind of just narrow it down to kind of a somewhat specific process, right? And so I'm saying, you start off with your givens. What your givens are trying to tell you. Start seeing if there's anything else in those triangles. Go to, proving triangles are congruent, and use CPCTC. That's your 5-step process, okay? And maybe at the end of this video, I'll write that down for you, okay? So let's move on to problem 8 here. Okay, in problem 8, we have a little, kite-looking guy, and we're trying to prove that, or we're being given that triangles are congruent. So that should already tell you that we're going to have to be using some CPCTC here, right? That's something that we do after we know that triangles have been proven congruent, right? And so triangle PRX, that's this triangle right here, is congruent to triangle PSX, right? And so now we want to prove, given that PRQ, that these two big triangles are congruent, must be. Yeah, PSQ, right? We want to prove that those two things are congruent. Okay? And so, let's start off. We know that triangle PRX is congruent to triangle PSX. That's given. Okay? And so if we know that, we just have to start pulling off different things, right? We have to start pulling different things from this with CPCTC, okay, to show that these things are actually congruent, right? To show that these two big triangles are actually congruent. So what are some things that we know, right? Well, we know that since we know these little two triangles are congruent, right, we can see that these two big triangles, they share angles, right? We can call this angle 1 and angle 2. Right? These two triangles, they share angles with the big triangles. And so we know that angle 1 is congruent to angle 2 by CPCTC. Okay. What else? Well, we also know Well, let's go off again here. We know that PR is congruent to PS, right? That's also by CPCTC. Right? Hopefully that, that idea makes sense, right? These are just angles and sides in the triangles that we already know that are congruent, right? But the important part of the reason why I'm pointing these ones out is because they're shared with the big triangles, right? And if they're shared with the big triangles, they become of importance to us, right? So now we have an angle and a side of the big triangles. What else do we have? Well, remember that this side is shared by both of those big triangles. And so now we have a side, angle, side. That's SAS. We're good. That's all we have to do is prove that right here, right? That you have, where is it here? PQ is congruent to itself, right? That's what the segment is, PQ. And that's by the reflexive property. Okay, and then the last thing here, we can then say that these two triangles are congruent, right? Triangle PRQ is congruent to triangle PSQ. By SAS, right? Because we have a side, an included angle, right? So an angle between the two sides. Okay, so that's why it's SAS and not something different. Okay, so that's problem 8. Now, before we get into our last 2 problems, right, we're almost done here. We have just 2 more to go. If you want to take a 5-minute break here, feel free, just so you're not going to get burnt out towards problem 10 or anything like that, right? Just kind of take that little maintenance break. Okay, come back, and then we'll finish up here. Okay, and assuming that you've done that, let's hop back into our problems. Okay, so again, 2 more to go here. We have problem 9. We are given that MR is congruent to PR, and we're given that MS is congruent to PS. Okay, so for this proof, we're just given things that are congruent. That's not going to tell us anything else about the triangle other than these 2 things being congruent, right? So let's just start writing these things down, right? We know that MR is congruent to PR. Okay, we'll write that down. And we know that MS is congruent to PS. Those are given. And we'll write down MS. Where's that? Here, right here. The segment here is congruent to PS. Okay, and we want to prove that MX is congruent to PX. So we want to prove that these 2 things are congruent. Okay, so these 2 lines right here are part of, we have a bunch of different triangles here that we can try to look to prove congruent, right? We have these triangles, okay, which include this side. We have these triangles, right? And we also have 2 big triangles here. And so there's a lot of different things that we can do here to, prove congruence, right? But I mean, on that last one that I just did, right? If you look at these 2 big triangles, look what we have. We have 2 congruent sides, 2 pairs of corresponding congruent sides, right? And when you have that, I mean, you just want to look to that 3rd side, right? See if you can get side, 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 or maybe an angle and get side, angle, side. Well, we know that we can get this 3rd side here, right? Because it's shared by both triangles. It's congruent to itself. That's the reflexive property, guys. Right? And now that we have that written out, we know that the 2 big triangles are congruent. Okay, and remember what I said. Whenever you can prove that 2 triangles are congruent, do it. right? Any two triangles. I don't care what they are. It just might help you somehow with CPCTC. Okay, so we know that these two triangles are congruent by SSS. Okay, so it's really just a matter of like looking around and seeing what are the different possibilities. What's the different things that I can do, with these triangles, right? We saw that we could have maybe tried to pull an SAS or SSS, or you should be able to see that reflexive property right off the bat, right? And just have it in the back of your mind for later. Here, we wanted to apply that right away, right? Because all we needed was one more side, and then we would have two big triangles that are congruent to each other. Okay, let's get back into the problem. So now that we know that these two triangles are congruent, we know a couple different things, right? And if we start working towards getting, we can try to do a couple different things here, right? We can try to get this triangle congruent, or these two triangles right here congruent, or we can try to get these two big triangles congruent, right? From here, I guess it's kind of your choice, whatever you see that you want to do here. Okay, we could try the top two, right, and say that angle 1 is going to be congruent to angle 2. How do we know that though? If you're wondering like, whoa, how'd you do that? Angle 1 is going to be congruent to angle 2 from CPCTC, right? Those angles are shared by the two big ones that we just proved that were congruent. Okay, and so we know that that's going to be congruent, and now we have a side and an angle, and we know that we have a side and an angle. Either we, from our side angle, either we get another angle and then we have AAS, or we can get we don't have it's not like that. It's angle side. Yeah, we have an angle and a side, and either we can get an angle on the other side, right? We can get an angle over here, right, which is actually this thing right here, or we can get a side, right? We can get this side. And hopefully you realize, I don't really see how we can do this one right here, right? It's not part of the two bigger triangles. But you should be able to see that this side is itself, right? And so we have another x that we can draw right here, right? Segment RX is congruent to itself. Right, how? By the reflexive property. And since we know that, we now know that these two upper triangles are congruent. Okay? So that's really nice. And I think I just drew that and I undid it. But yeah, so we'll write down that these two triangles are congruent. Okay? That is triangles, I believe MRX, right? MRX and PRX. Right? How are they congruent? Remember, we just said it. Side, angle, side. Side, angle, side. Apologize if you can hear my dogs. They're going crazy right now downstairs. Maybe my dad's home or something. Yes, I live with my parents. I'm a college student, okay? But anyways, yeah, so now that we know that these two things are congruent, we know that these two triangles are congruent, we know that MX is going to be congruent to PX by CPCTC, right? We know that because these two sides are part of these two upper triangles. And so we can write that down. And that'll be it for our proof. Okay, so that's the answer for that. There was a point there though where I chose whether to go for the upper triangle or the lower triangles right here. You could have done either one, right? You could have shown that these two angles are congruent with CPCTC, right? And then you could have proved that this segment is congruent to itself with reflexive property. And then you would have been able to prove that these two lower triangles are congruent, right? And if you're following me so far, you could have just then said that these two sides were congruent using CPCTC. Okay, so there's other ways that you could have went about this proof, right? And that's, I think, I don't want to sound like a super nerd, but I guess there's no avoiding it now. That's the beauty of it. Okay, and yeah, hopefully not too many of you just threw up in your mouth hearing that. But anyways, problem 10 here. So let's go. We got our last problem. We're given that segment BF is congruent to segment CF, and that segment EF is congruent to segment AF. Right, that's given. Cool. So we want to prove now. So if we mark that here, DF or BF, right? Congruent to CF right here. We have the EF, which right here is congruent to AF right here. Okay, and with that, right, we want to prove that DC is congruent to BG. So we want to prove that this is congruent to this. Okay, and so how are we going to go about doing this here? Right, so we have that, we have pieces of these two triangles right now. Okay, and so, it looks like since we have those two sides that are congruent, right, we can't do like a non-included angle, right? Or else we would get this word, you can say like donkey. So my old geometry teacher also used to call this the donkey postulate. So that we can't use that one, but we could use maybe side, side, side if we can get these two sides congruent. But I don't really see a good way of doing that. What's another possibility? Well, there's another one that's angle, angle, side, right? But we don't have two angles right now. We have two sides. So we should probably look for a postulate that has two sides in it, right? And a good one is side, angle, side, right? So can we get these angles to be congruent? Well, yeah, right? Those are vertical angles. So actually, I'll keep that there. And we'll write down that we'll call this angle 1. I don't want to write that too small so you can't see it. But angle 1 is congruent to angle 2. Right? By vertical angles. Okay? And since we know that these two triangles are congruent. No, that doesn't tell us that the big two triangles are congruent, right? No, that doesn't tell us that segments DC is congruent to segment BG, right? But it at least gets us congruent triangles. And remember, I'll say it again, you always want to try to prove that two triangles are congruent, right? If you can do it, go ahead and do it, because CPCTC is extremely powerful. You end up with so many different congruent sides, so many different congruent angles, and once you have that, you're set. Like, you have so much information to deal with, and you can just go off and do whatever, right? In the last problem, we started off with, a little bit of CPCTC, right? We started off by proving that the two big triangles were congruent, and then we had a little bit of CPCTC. And that allowed us to go whatever route we really wanted to. We could have done the upper triangles. We could have done the lower triangles, right? Whatever we wanted, because CPCTC gave us so much information. But anyways, so now that we know that those two angles are congruent, we know that triangle, we'll call this BAF, is congruent to triangle CEF. Right? And that is by side, angle, side. Again, we have two sides, and we have the angle in between those sides. And so the A goes between the S's in the notation. Okay, great. So where do we go from here? Right? What do we do? Well, maybe we can try to move to see if we can get these two big triangles congruent now. Right? Maybe that's something we could do. And how could we do that? Well, we at least know that, this angle and this angle, which is shared by both the triangles that we just found congruent and the two big triangles, right? That's shared. And so maybe that angle would be of use to us, right? It at least gives us a side and an angle And so we have a little bit of freedom as to whether we want to do, another angle, or maybe we can do another side. So I think it'd be good to point out that angle B is congruent to angle C, right? And so that is going to be just from CPCTC, right? Because we found that those two triangles are congruent, this is something that happens because of that. And that line's not straight. I'm going to fix that. There we go. Okay. But now you might be wondering, well, where do we go from here? Right? Can we say that these two lines are congruent? Well, that's what we want to find in the first place. So maybe not. And I don't see a way that we could do that right now. Right? But so that kind of eliminates our chances of doing an SAS again. But with a side and an angle right next to each other, another thing that you can do is get a angle on the other side of the side and get angle side angle, right? So whenever you have an angle and a side next to each other, these are the two things that you should be thinking about, right? Or, maybe we get an angle right here well, we want to prove that the two big triangles are congruent, so we would need this angle over here, right? And that would be angle side. Right, two angles and a non-included side. So by non-included, I mean not the side that's right in between the angles, or that would be angle side angle. Well, so what you got to see here, what the trick is, right? We have an angle side. We can prove that the angle of the big triangle, which is this thing right here, is congruent to the angle of the big triangle on the other side. Okay? And see, this is the hardest part. I think this actually might be the hardest thing to see of all of the proofs that we've done so far. Okay, I want you to be able to see that this is a vertical angle and this is a vertical angle, right? This entire thing. I did just draw across that line for a reason, okay? Because remember, we're trying to see these two big triangles. And so, how do I know that they're vertical angles? Well, just get rid of this line and you might be able to see it a little bit better, right? We have two lines intersecting each other. You should be able to see that this is definitely congruent to this now, right? You just kind of got to see past that. You got to see past this line that kind of cuts through, okay? And since that's true, right, we can label that as, angle BFJ is congruent to angle, what's going to be that? It's going to be CFD, right? Because they're vertical angles. And now that we have that, we have angle side angle, right? We have that those two triangles are congruent. Okay? We have the triangle BFG is congruent to triangle CFD, right? We have that that's by angle side angle. Okay? And since we have that, we can now show that since, BG and DC are the corresponding sides of these congruent triangles, well, these are corresponding parts of congruent triangles, and, that's what I just said is corresponding parts of congruent triangles. And so, what does CPCTC mean? Well, that means that those two corresponding parts are congruent. And so we know that segment DC is congruent to segment BG. Okay. And so that's really it, right? Don't try to, log off the video yet, right? Because there is one more thing I want to do, okay? And that is give you a good idea of, a step-by-step process for these proofs, okay? And, that's because we went through all these problems, right? And hopefully you tried some of these on your own before I did them, right? But hopefully you got a lot of information from me doing them. But I want you to be able to do these on your own well, right? Because you're going to have at least one question of this on your final, okay? And so let's just come up with a quick step-by-step process, right? The way I would go about proofs, right? And all proofs are different, right? But here's my recommended step-by-step. Here's the one that I've been preaching this entire video. Okay? The first thing is to write down your givens. Okay? Write down your givens. That's the first thing we always start with, right? We always have one thing that's a given. Okay. After we talk about our givens, though, we want to see, is there anything that the givens give us? In this thing, no, they didn't, because our givens were already saying that things were congruent. Sometimes we have givens where it doesn't tell us congruence right away. Like, these last few have not been good examples, but in problem 7, I think this is, right? We got that, we got that G is a midpoint of BD. That was one of our givens, right? That wasn't saying that two things are congruent right off the bat. And so what we were able to do, right, is say, well, from that, we know that these two things are congruent, right? That's the definition of a midpoint, okay? And so that was the idea, right? We just wanted to know that from the givens. And so that's step 2, is to identify anything else that the givens tell you. Okay. Step 3, okay, is to, and this entire time, you want to be working towards what you're trying to prove, right? So there was times where we could have shown vertical angles, but it wouldn't have helped us at all, right? And so, just try to not do too many things in your proof that are just completely useless, okay? Like when you have two triangles are congruent, you don't need to show that every single side is congruent to, all that stuff, and all the angles are congruent by CPCTC. Only just take the stuff that you need, so you don't have to so you can save time, right? That's a big, it's a big time saver, especially on your final or especially on a midterm or whatever. So 3 would be identify anything else in the triangles or whatever, in the shapes, that could help. Right? And some examples of that are the reflexive property, right? Vertical angles. Okay? All that stuff. Okay? Those are the main 2, to be honest. Like, those are the real things that you want to look out for, is reflexive property and vertical angles. Okay? Those are huge. But once you do that, you're ready to prove that two triangles are congruent. So that's it, right? Once you've done that, if you've done that properly, you can prove that, two things are congruent. Or, you can either do the sides, right? Or let's just say triangles for now, right? Because if you have a proof that goes further, right, and it's not just solved by you, it's not just solved by you finding that two triangles are congruent, or that you immediately finding that two segments are congruent, right? It needs you to actually prove that two triangles are congruent. Well, from there, if it's asking anything else, you can go ahead and do that, right? You can use CPCTC to prove anything else that you need. Right? Like that's a pretty, general process, right? That's, I think, a good idea of how to tackle a proof. Okay? And if you follow that step-by-step process, you really shouldn't run into too much trouble. Okay? As long as you know your stuff, you know what an angle bisector is, you know what a midpoint is, you know what the reflexive property, what vertical angles are. Okay? If you know those things, you know how they work, you know the different postulates, SAS, SSS, right? CPCTC, okay? You'll be fine with proofs, actually, because every proof is essentially like a puzzle, right? But you can kind of make that puzzle a little less puzzling if you just follow like a step-by-step, okay? So let me know in the comments if you have any questions. Feel free to subscribe and support me on Patreon if you want to. And yeah, let me know any other videos that you want to see made. I'll be coming out with a full geometry course very soon, and when I do, that'll be right in the description. So maybe it'll be out by the time you watch this video. Anyways, thanks guys. I'll see you soon.